Okay, so in this lesson, we're going to continue on with systems of equations, and we're going to do another algebraic method to solve a system of linear equations, and that is called the elimination method. So this one is kind of similar to substitution method and what we just did, but we're going to kind of do it a different way. So elimination method is kind of like how it sounds. When you eliminate something, you get rid of it. So what we want to do is we want to find variables that we can get rid of or eliminate. Now, we can eliminate variables if they are opposite coefficients, and I'll talk more about that for a second. But first, I want you to look at this example 4. And this video might be kind of long because I want to do, I'm going to go through number 10, and we're starting on number 4. But if you think it's easy, just fast forward through and pause it if you need to. I'm not going to kind of go fast, but you're welcome to pause it, work it with me, participate that way that you know how to do it. If you don't put the pencil to the paper and do some of these with me, you're probably not going to do so well when you get to do the worksheet. So please make sure you're participating with me. There's going to be a few of them at the beginning that are really easy. Of course, at the end, it's going to be a little bit more difficult. All right, so first I want you to look at how number 4 is set up. They are similar in how they look. Notice that the x's are all lined up on top of each other, the y's are on top of each other, and the constants at the end are on top of each other. We call that standard form of a linear equation, ax plus by equals c, if y'all remember that. So we do want them to be in standard form, x then y equals a constant to do elimination, so that is important. And if that is the case, like number 4 is, then we are ready to eliminate. Now, to eliminate in a system of equations, you're looking for opposite coefficients. Make sure I spell it right. Now, we know a coefficient is the number that goes with the variable. All right, so we want the coefficients to be on the same variable, so either the x coefficients or the y coefficients, and we want them to be the same number but opposite signs, like a +5 and a -5, or a -13 and a +13. So if you're looking at these two equations, they're stacked up on top of each other. The x's are right here. There's my x's. And my y's are right here. Then if you notice that the x's, I have a +2x and a -2x. So those are what we call opposite coefficients. So what we're going to do is we're going to draw a line underneath both of the problems. And if I were to add columns like you did in elementary school, +2x plus -2x equals 0x, right? So that's why we can cancel these out. So we can eliminate our x's because they are opposites. And if we were to combine the opposites, then that would get us 0. So those cancel out because they make 0x. Then we're going to add our y's down the column. So that's +3y plus 5y equals 8y. So you're going to write 8y down here. Copy your equal sign. And then you're going to add your constant terms. +11 plus 13 is 24. And now you go across this row and you have a tiny little equation. 8y equals 24. So you're going to divide both sides by 8. And y equals 3. So we're almost there. We have one of our variables solved for. So we have y solved for, we've got to get x solved for. So to solve for your second variable, you're just going to pick one of the original equations and plug in the variable that you just solved. So we just got y equals 3, and so I can replace that right there for that y. So I'm going to copy 2x plus 3 times 3 equals 11. So the variable that you already know, you plug it into one of the original equations. Make sure you use an original equation, okay? So 3 times 3 is 9. So I have 2x plus 9 equals 11. Solving for x, so I'm going to subtract 9 on both sides. 2x equals 2, divide by 2, and x equals 1. So now I have my x and my y. The solution is the ordered pair 1, 3. Make sure you write it as an ordered pair, x and then your y. So again, you're looking for opposite coefficients, and if they have the same number in front of the same variable and they're opposite signs, one's a positive, one's a negative, you can eliminate that variable. All right, let's look at number 5 here. 7x minus 4y equals negative 30. 3x plus 4y equals positive 10. So pause the video, copy that down so you can be ready to work with me. So if I look, my y values right here are opposite coefficients. I have a negative 4y plus 4y. If I combine those two, I get 0y. So I'm going to draw my line right here, and I'm going to mark out my y's because they make 0y when I combine them together. And now I'm going to go combine my x's. Positive 7x plus 3x is 10x. So I'm going to write that down. Come over here. I'm going to have a gap right there where my y's are. That's okay. And then I do my constants. Negative 30 plus 10 is negative 20. And then I divide by 10 on both sides. It's okay if you have that big gap there. It always happens. And then I have x equals negative 2. All right. So there is x equals negative 2. Well, I'm going to plug that into the second original equation. It does not matter which original equation you plug it into. I typically go for the one that has smaller numbers, or whichever one just looks easier. So I'm going to use the second one this time just because it has smaller numbers. Again, it does not matter. Some people always do the first one, whatever your preference is. I like to pick smaller numbers. So I know my x is negative 2, so I can replace the x spot with negative 2. So I'm going to say 3 times negative 2. Copy the rest. Plus 4y equals 10. Then I'm going to simplify. 3 times negative 2 is negative 6. Plus 4y equals 10. I'm solving for y. So I'm going to add the 6 on both sides. 4y equals 16. Divide by 4. And y equals 4. So I have my x and my y. So I write my ordered pair. X before y. So negative 2, positive 4 is my solution. All right. So number 6, they're starting to get a little bit more complicated on me because if you notice on number 6, I don't have opposite coefficients because the 4x and 5x do not cancel out. 3y and 3y, they have the same coefficient, but if I combine those two together, I get 6y. I don't get 0y. So those do not eliminate. So when I have variables that do not eliminate right off the bat, then I have to multiply one of the rows or both of the rows by a number to get them to. Now, this one's an easy fix because they're already the same coefficient. I just have to make them opposite coefficients. And to make something opposite, you change the sign. Well, to mathematically change a sign, all you have to do is multiply it by negative 1. Now, the thing here is that these are part of an equation, and we know that mathematically, if you do something in one part of an equation, you have to do it to all parts of the equation. So I'm going to multiply this whole first equation by negative 1. Now, you could multiply the second equation by negative 1. Okay, so it doesn't really matter which one you do. Just make sure you multiply the whole thing, all 3 terms by negative 1. So I'm going to change my first one to negative 4x when I do that. The second term to negative 3y, the last term to negative 2. So that is my first equation. I multiplied everything by negative 1, and that changed all their signs. I'm not changing the second equation. So I'm going to copy the second equation just like it said originally. Okay, so the second equation is staying exactly like it was. So now if I look at my y's right here, let me see if I can get my highlighter. Now I'm looking at my y's right there, and they are opposite signs. So now I can eliminate my y's and then combine my like terms. So negative 4x plus 5x is positive 1x equals negative 2 minus 2 is negative 4. Well, that's just spaced out, but I can squish it together. X equals negative 4. So that one is already solved for. All right. And then all I have to do is plug -4 into one of my original x's in one of my original problems. I'm just going to do it in the second one. That's why I use different colors, so that way I can see that my black problems are my originals. So I'm going to say 5 times -4 plus 3y equals -2. So I'm using the second original equation. You can use the first one if you prefer. And I'm going to simplify that. 5 times -4 is -20 plus 3y equals -2. I'm going to add 20 to both sides. 3y then equals 18. Divide by 3, and y equals 6. So y equals 6, and put them together in an ordered pair. I have the ordered pair -4, 6. So if I were to be graphing these two equations, I put them in slope-intercept form and graphed them on the line, which you could totally do, they would cross at the point -4, 6. So even though we're doing elimination, it still ties back into graphing because these are linear equations. Just a little tidbit of extra information. All right, number 7. So I got the equations 2x minus y equals 6 and 3x plus 4y equals -2. Again, I do not have my x's won't eliminate and my y's won't eliminate because they are not opposite coefficients. I'm looking for same coefficient with opposite signs. Okay? So again, if that doesn't happen, you're going to have to multiply a little bit. So this first one, that's a -1y, right? In front of that y. And the second one has a positive 4y. Well, if I was to multiply that -1 by 4, I would get -4, which would cause the y's to cancel out. So what I'm going to do is I'm going to multiply the whole first row by 4 because you can't just do part of it. You got to do the whole equation, constants included. Okay, so I'm going to draw a line, and I'm going to multiply the whole top row by 4. So 4 times 2x is 8x. 4 times -1y is -4y. And 4 times 6 is 24. All right. We're not multiplying the second row by anything. So I'm going to copy it just like I said I am. I'm going to copy it just like it says. Okay. Draw my line. Now my y's are -4y plus 4y. That makes 0y. So cancel out your y's. And then you combine your x's and your constants. So 8x plus 3x is 11x. Skip over here equals 24 minus 2 is 22. Divide by 11, and x equals 2. There's my x value. Plug it into one of the originals to get your y value. I'm just going to use the second one since I did so much stuff to my first one. So x goes in for x. So 3 times 2 is x from my answer I just got. And then copy the rest, plus 4y equals -2. And then I simplify. 3 times 2 is 6. Copy the rest. Subtract 6 on both sides. 4y equals -8. Divide by 4. And y equals -2. I have an x and a y. Put them together as an ordered pair, x then y. So 2, -2 is my ordered pair. Okay, let's see what we got next. All right, so this one, I'm going to have to think a little bit. My x's don't cancel out, and neither do my y's. So I need to somehow think of a way to get opposite coefficients. Now, I could multiply the top row by -11, but when I multiply that number by -11, I'm going to get 99. Sure, that's kind of a big number, so I don't want to do that if I don't have to. But if I can somehow get my x's to eliminate, maybe that'll save me a little bit of trouble using big numbers. So if you think about it, the smallest number that 2 and 4 both go into is 4 because 2 goes into 4. So if I can make that 2 change to a -4, it would cancel out with that positive 4x. So to get 2 to become -4, I could multiply that by -2. Okay, so think about what you can multiply a row by to get it to where it has opposite coefficients with the other row. So that way I can eliminate my x's. So that's what I'm going to do there. So everything in the top row is going to get multiplied by -2. So -2 times 2x is -4x. And I don't know why stuff just deleted there. Uh-oh. Sorry about that. I don't know what's going on. Did it again. So that's -4x minus 2y equals +18. So -2 times the top row. Got me that. And then I'm going to copy the second row just like it was. Hopefully that one didn't change on me. I don't think it did. All right, so now I draw my line. And now my x's will cancel out because I got a -4x plus 4x. Those make 0, so those cancel out. -2y plus an 11y. When I combine my terms, I get 9y equals 18 plus 9 is 27. Divide by 9, and y equals 3. So now I've got my y value. I'm going to plug it in this time for my first original before I multiply because those are just smaller numbers. Okay, so I'm going to plug it in right there. So I know y is 3, so I'm going to say 2x plus 3 equals -9. So where they had a y, plug my 3 in. So now I'm going to subtract 3. So 2x equals -12. Divide by 2. X equals -6. So I got x and y. Put my x first in my ordered pair. -6, 3 is my solution. Okay, I think these last two are my most complicated. And because there's not an easy fix to get a variable to cancel out here, unfortunately. So if you notice, my x's are not even the same, or I can't just multiply, like 2 doesn't go into 3. And same thing with my y, 3 doesn't go into 4. So that means I'm going to have to multiply both rows by something to get my variables to cancel out. Now let's think about it. So for the x's, the smallest number that 2 and 3 both go into is 6. Okay. For the y's, the smallest number that 4 and 3 both go into is 12. So if you want to keep your numbers smaller, go with the one that has the smallest number that they both go into. Okay, the smallest least common multiple. All right, so I'm going to work on these on the x's, I believe, and I want them to become 6 and -6. So to get 3 to become 6, I multiply it by 2. And to get 2 to become 6, I multiply it by 3. But I want them to have opposite signs. So what you need to do to make them have opposite signs is give one of them a negative. Now, you don't want to do both of them a negative because then you'll have -6 and -6, which doesn't cancel out. So only multiply by a negative on one of the rows. Okay, and it doesn't matter which row. I just stuck it on the bottom. You can put it on either one. So this is one of those crazy ones where you're going to have to multiply both rows by something to get the variables to cancel out. So I'm going to multiply my whole top row by 2. So 2 times 3x is 6x. 2 times 4y is 8y. And 2 times -25 is -50. So there's my top row. My bottom row, I'm multiplying all three terms by -3. -3 times 2x is -6x. -3 times -3y is +9y. And -3 times 6 is -18. All right, draw my line. Now, my x's are ready to cancel out. I got a +6x and a -6x, so those make 0. So those go away. So now my y's, +8y plus 9y, 17y, equals -50 minus 18 is -68. And I divide both sides by 17. And I get y equals -4. There we go. All right, I'm going to pick the second original equation because those numbers look a little smaller. So I'm going to use those right there. So again, when you want to plug into the originals because they're smaller numbers, and that's your kind of your whole point. Make it a little easier on yourself. So where they have a y, I'm going to replace it with -4. So I'm going to say 2x minus 3 times -4 equals 6. So be careful with your signs there. That's -3 times -4, which is positive 12. So 2x plus 12 equals 6. And then I subtract subtract 12 on each side. So 2x equals -6 divided by 2. X equals -3. And then again, write your ordered pair, x then y. So -3, -4 is my solution. So that's really as difficult as it gets is when you have to multiply both rows by different numbers to get them to cancel out. Unfortunately, it happens. Okay, you just want to make sure when you do it, you use opposite signs if they're already the same sign. Practice makes perfect, guys. That's how I got better at this. That's how you'll get better at this. All right, let's do one more. One more. This is my last example. So if I look at these to eliminate, the x's are not ready to eliminate, and neither are the y's. So I want to see which one would be best to eliminate. So look at my x's. 2 don't go into 7. Look at the y's. 3 don't go into 4. Okay, so I can't just multiply by one row by something. I'm going to have to multiply both rows. So what you want to do is you want to find the lowest number that they both go into. So 2 and 7 both go into 14 is the smallest number. And 3 and 4 both go into 12. Now, 14 and 12 are relatively close to each other. So it's not really going to make a difference whether you choose the x's or the y's. And I'm going to use y's, and here's why. They already have opposite signs. Okay, so I'm not choosing y because it's a smaller number necessarily this time. I'm going to choose it this time because the y's are already opposites, and there's really not a lot of difference in the size of 14 and 12. So I'm going to use my y's. So since they're already opposite signs, I'm just going to say what times -3 makes -12? Well, that's going to be +4. And what times 4 makes 12? That's +3. Okay, and again, I'm not going to use a negative to multiply with because they already have opposite signs. So if they have the same sign is when you want to make one of them a negative. But since they're already opposite signs, I don't have to worry about that. So first row, I'm multiplying everything times +4. So 4 times 2x is 8x. 4 times -3y is -12y. 4 times 6 is 24. Then I'm going to multiply the second row by 3. 3 times 7x is 21x. 3 times 4y is +12y. And 3 times -8 is -24. Draw my line. And now my y's are opposite coefficients, so they cancel out. And I don't know where that just went. There they go. Sorry about that. And then 8x plus 21x is 29x. Skip a space, equals 24 minus 24 is 0. Divide both sides by 29. And y'all know 0 divided by a number is just 0. And I don't know why people freak out when they get 0 for an answer, but it's okay. You can get 0 for answers sometimes. All right, so now I'm going to plug that into one of the originals. I'm just going to use the top one because the numbers are slightly smaller. Not really a big difference in this one. Sorry. So they have an x, I'm going to plug 0 in. So 2 times 0 minus 3y equals 6. Well, 2 times 0 is 0. So that's just -3y equals 6. Divide by -3, and y equals -2. So x and y, my ordered pair is 0, -2. So that is the elimination method. Please shoot me an email if you have a problem with the problem, and I'll be glad to show you how to do it. And now you're able to work on all of worksheet number 4. On 5 through 12, you can use substitution and elimination. 1 through 4, obviously, you have to graph. So now you have all the information for systems of equations. Have a good rest of the day.